Dear students, today let us know about different types of fossils. You know already fossils are remains of plants or animals or bacteria that has been preserved naturally in the rock or the sediments. So they include whole organism or remains of the organisms such as teeth, bones or shells, leaves like that, or the traces of the organisms. So they may be the footprints or they may be the burrows, fossilized burrows like that you can see. So these fossils are broadly classified into two types, body fossils. So these are the whole organism preserved in the sediments or else the part of the organism preserved. So that is body fossils concerned with the body of the organism. Then the trace fossils, they are the traces of the living organisms. Traces of the living organisms includes impressions of the living organisms or else the footprints or else it may be the burrows or borings that is that was made by the ancient animals. So those are all belonging to the trace fossils. So the body fossils also, they may be unaltered as it is without undergoing any change. The whole organism is preserved unaltered or else altered. They might have undergone some chemical modifications, some salts, calcium carbonate or the silica may replace the organic matter. So this is chemically modified or altered remains. So let us know more about these different types of fossils and the examples. So the body fossils, in this body fossils the types is entire organism preserved. So these entire organisms can be preserved fossilized in the form of refrigerated form or frozen form or else mummification or else preserved in the amber or resinous substance. Refrigerations, entire organisms are preserved without any decay in frozen condition. So example is the woolly mammoth or mastodon. So it has close relative of modern Indian elephants. They have become extinct about 10,000 years ago, but they have been well preserved in Arctic tundra in the ice block. You will able to see here, this is the one, the just frozen and it has remained for thousands of years like that, and even scientists they can able to draw the blood from the circulatory system, so much freshly preserved their wool and hairs and all this. So this woolly mammoth of lived in the period of Pleistocene period, and you can see the fossils of about 1 lakh year old. So they have become extinct about 10,000 years ago. So these are in the Siberian region or else in the Arctic region you will able to see. So this is what you can see, the entire organism refrigerated or else frozen in the for a long time in the ice. Entire organism preserved in the form of mummies. So mummification. So mummification, that a compaction or mummified plants. In this type of plant fossil, the plant or the animals or their parts, they get compressed by vertical pressure and undergo quick drying. So there is the quick drying, pressurized quick drying. So that is making this as it is, they can be how exactly the Egyptian mummies, so they are they remained, you can see, about 6,000 years old bodies they have in the Egyptian mummy. Similar, you can see, it's called mummification, or else they may be immersed in the tar and remained as it is. So this is a mummified dinosaurs about 110 million years old. So this is how the entire organism preserved or mummified. Then entire organism preserved in the umber or resinous substance. So this is, we can see the fly in the umber. This is what you can see, the spider in the umber. Whole organisms are preserved intact in the medium which protects decay from bacterial action such as umber or resinous substance. So of the plants, so for example, the resinous substance exuded from the plant, it covers the insect present on that, and it get preserved as it is for millions of years without undergoing any decay. So these are the examples for body fossils, the entire organism preserved as it is. Next, unaltered remains of hard parts of organisms. So these are also, they have not undergone any alteration, but they are the hard parts. They are not undergoing decomposition, and they will remain in the sediments as it is in their original form. So many, you will find here the many exoskeleton, endoskeleton structures of vertebrates, invertebrates are preserved in sediments in an unaltered state. The shells of invertebrates, mollusca, you will find, and the single celled organisms, like this is a microscopic picture under electron microscope. These are single celled shelled protozoa. You have studied last sem foraminiferans or else Eliphidium, Polystomela. So the shells as it is preserved, or else the hard parts of the echinoderms, starfish, preserved as it is in the sediments. So then you will find the teeth of shark. So you will find the claw in the case claw of the dinosaur, the bones. These are the entire you can see the skeleton preserved. This is the stage of horse evolution. So the early horse, Mesohippus, it is preserved in the sediments in the So similarly, you can see the woody tissues of the plants may be preserved in their original shape without any alterations. So hooves, claws, nails, all these hard parts of the organisms preserved in the sediments without undergoing any change. This is going to form the unaltered remains of hard parts of organisms. Next, chemical alteration or altered hard parts of organisms. So they undergo different types of chemical modifications. So the one is carbonization. Carbonization means, so what happens, you can see, when in the sediments, when they are preserved in the sediments, there is a decomposition activity, that the organic matter get decomposed. So decomposing of the body of the plants and animals leave a thin film of carbon on the sediments. So this as though it is like a painting, you will able to see. So this is what you can see, the carbonization. So all the organic matter decomposed, leaving a thin layer of carbon, just somebody has painted like this. You can see this is called carbonization. Similarly, you will find the on the rock as though somebody painted the fish. See, you will find similar, you will find exact body outlines and of the extinct swimming dinosaurs, jellyfishes, worms, all these are preserved on the sediments. So these are called the chemical alteration of the body parts or hard parts. This is what you can see, the carbonization. Then petrifaction or else permineralization. Permineralization, where you can see the decomposing organic matter of the body was replaced by mineral deposition. Due to percolation of mineral rich water, original organic matter will be replaced by calcite, calcium carbonate, silica, silicon dioxide, or pyrite, iron dioxides. So, iron salts, pyrite, you know that. So, the dinosaurs bones and the woods are fossilized. So, you will find that this is the wooden fossilized, but there is no wood material. It is entirely replaced by the minerals. Similarly, you will find the dinosaur bone. So, even though this looks like bone, there is no bone material in this. Entirely this is the one pyrite, the iron salts, they have replaced the organic matter. So, petrified means turning to stone, they change into stone. That means mineral salts replaced the organic matter. Petrified fossils are fossils in which minerals replace all parts of the organisms by the mineral salts. So, petrifaction or permineralization, sometimes specific structures are replaced by specific minerals. Lime or calcium carbonate replaces the silica of spicules, or else you can see you will find fossilized, you will find nautilus. So, then silicon dioxide forms the nails and the hairs. So, nails and the hairs replaced by the silica. Then you can see the bone material replaced by the you can see the or else you can see the iron salts. So, here you can see this is the silica, this is the dinosaur bone replaced by silicon dioxide. So, phosphatized embryo. So, embryo calcareous materials shell, it is replaced by phosphate, you can see phosphatized embryo. Here in this petrified wood you will find different mineral, you can see the salts. So, the copper salts, manganese salts, then cobalt, then iron oxides. So, you will find the different colors. So, thereby you can see these how the organic matter replaced by these mineral salts. So, there is you will find there are dolomites, that is the magnesium carbon, you can see the carbonates, calcium carbonates, magnesium calcium carbonate sediments, they form the ancient coral reefs. So, similarly you can see the gluconate, they are nothing but containing crystalline lime with the trilobite fossil. So, this type you can see where you can see the mineralized salts, they replace the original organic matter. Then trace fossils. So far you have studied body fossils. Trace fossils are the traces of the organisms lived, those are get fossilized. They are also called ichnofossils. Trace fossils are the markings or impressions in the sediments made by the activities of the organisms or the organism itself. They result from the movement of the organisms across the sediment surface, that is you can see the footprints fossilized immediately and remained in the sediment. So, that is what you can see, they are called trace fossils. Trace fossils are classified as they are called as ichnofossils, which reveal the habitat and behavior of the fossilized animals, whether it is a herbivore, carnivore, whether the animals are fighting. So, all these details we can get by studying the footprints. So, here you can see the footprints of dinosaurs, you will find. So, it provides information about the ancient water, depths, paleocurrents, availability of the food, sediment deposition rates. So many aspects geologists and paleontologists can able to understand by studying these ichnofossils. So, ichnofossils they are classified further molds and casts. Molds are the imprints of the organisms in the sediments. They are fossilized impressions made in sediments. You can see this. So, fossilized impressions. So, you can see the shell buried on the sandstone may be leached off, leaving a mold of the shell on the sandstone. So, there are two types of molds. External molds, imprints of the outline of the organism. This is the external mold. Then internal mold, imprints reveals the the external shape and internal details of the muscles, feathers and others, skeleton and all. So, this is what internal mold. Here you can see this form the external mold, this is the internal mold. Then the molds gives a negative image of an organism. So, there are the molds and casts. So, those are of molluscans. In the molluscans in foraminid shells are recovered in great number. Then the cast, if this mold filled with some sediments or minerals, then they give the shape of that particular mold and they are going to become the cast. So, this is you will see the casts of the mollusca, you will able to see. So, if this cast, the mold is filled with some sediments, that gives the cast. Then the tracks, they are the footprints. Tracks are produced by the feet of the walking animal. A continuous series of tracks made by one animal called track away. You can see these are the Homo erectus footprints. The Australopithecus. So, you can see these are the ancestors of the modern humans. So, their footprints in the sediments. Amphibian footprints on the sediment. Can you see the largest, the dinosaur footprint, that is they are exposing. So, the paleontologist can determine the leg length, the height of the animal, whether they walked on two legs, bipedal or for quadrupedal, its speed, whether it was running, walking, whether it was a carnivore, if they have the claw prints and all. And all these details they can able to extract from studying these footprints. You can see whether they are hoofed, if they are aquatic, webbed foot. Then footprints of dinosaurs recovered in 1500 sites all over the world, which includes coal mines, stone quarries, riverbeds, deserts and mountains in these areas. So, footprints of these ancient animals they have recovered, they are called the tracks. Then the trails are produced as a worm arthropod. They crawl on the sediments, you can see they get fossilized. So, then the belly of the animal they dragged on the ground. So, the trails of, you can see the crawling trails, you can see this is the trail of the trilobite, that is moved. So, the trails of the crawling traces left on in the sediment and usually linear and indicate the movement of the particular direction. There are also resting traces. So many traces traced, you can see the traces or the trails of the fossilized trails are recovered. You can see one can know whether it is a bilateral animal or radial symmetry or what type of head they have. All this information one can able to get by studying these trails. Then the burrows and borings. Burrows are the excavations of the animals made into soft sediments. So, these burrows on the wood made by the dinosaurs or else the insects or else ancient birds. So, you can see the molluscans or annelids, you can see like that. Borings are the ones, the holes made by the animals into the rocks, woods, hard sediments. Borings are circular. So, fossil borings of the molluscan sponges are also found. These are burrows and the borings, you can see. Then the coprolites and gastroliths. So, coprolites are the fossilized feces of the animals. Coprolites may be the feces, the fossilized feces. Coprolites may contain fragments of undigested food and it provide valuable information about the feeding habits of the fossil organisms, size of the organisms. You will whether they it's in the form of fecal pallets. So, you will find this is the fecal pallets of the dinosaur, fecal pallets of the fishes. Gastroliths are the highly polished stones. They are many birds they collect stones in their gizzard to churn the food. So, such stones are also present in the ancient dinosaurs gizzard. So, such stones are fossilized or they get in the sediments. You can see these are the gastroliths of the gizzard stones. They are used to grind the food in the stomach of the ancient dinosaurs. So, this is about the trace fossils. Even the trace of bacterial mats can be found in the rocks. They are called stromatolites. So, this is about the different types of fossils. Thank you.